My name is Abby Costello, and I'm the Watershed Education Specialist for Medina's Soil and Water Conservation District. And today I'm going to present one of the models that we let the public lease out, or teachers can use this also in classrooms. It's great for municipalities to show what's going on underneath our surface or our soil. So this is our groundwater flow model, and what it does is it shows basically a side section of landscape. You can see that there is the black area, which is the surface. There is the sand below it, which represents our soil and our soil profile, our ground that is going down. There is a dark layer that is our confining layer, such as like a clay layer, something that separates our unconfined aquifer from our confined aquifer. And the thing that's nice about this is usually we think of a landscape and we think of everything that's going on top of it. We don't always get to see a side section of it. So you can see that our model represents very much what we're seeing up here. We have our lower area, which could be a lake or a stream or a river. And as we fill up our model with water, that will represent when it's raining or if we have a reservoir of water that fills our groundwater. So what I'm going to do is start filling this up. We have our precipitation right there. And you can see that our groundwater, or our ground, is starting to fill with groundwater. Our sand is turning a little bit darker. Our river or lake right there is starting to fill up. It takes a while, as it would in nature, for our water to fill up all the pores and the spaces between the soil, the gravel, anything that's in the earth. So as that fills up, you can see that our lake or our river is starting to fill up too. So our water table is rising, and what the water table is it is the layer of earth or soil where below the water table is where all the gaps between the soil particles is filled with water. So it's completely saturated. So here you can see our river and our lake is filled up. It is starting to become saturated, and you can possibly see right there, at least on my side, now you can still see on your side a little bit, how the sand right there is not completely wet. And that is because that is above the water table. It is not saturated as right below. So, something that is really nice is we have different wells right here. And these wells are called piezometers. And piezometers are a way that we can monitor our groundwater. So what I'm going to do is I'm going to put some dye into our piezometers so that we can see if there is any flow, any movement within the earth. And this is something that we wouldn't be able to see regularly. We can see surface water moving, like through a stream and through a lake. You can see water flowing. When it rains, you can see the water go across the surface, but it's very rare do we get to see what's happening below the surface. So these piezometers are helping us figure out what's going on below the earth. So I'm going to fill specific ones of these piezometers with green, and we're going to see where this shows up. Okay, so I have filled my little syringe, and I'm going to put green right in here. And we're going to see if we see where that goes. So you can see that there's green inside of this line. And then I'm going to put some in this one too. So the reason why I chose these two piezometers to put green into are these are our two piezometers that go into our confined aquifer. So they go all the way down and they're right here. All the way down into our confined aquifer. Now I'm going to do blue for our area above the confined aquifer, so this is our unconfined aquifer. This means that any kind of pollution that hits the groundwater can soak into it. So I'm going to put blue down in there. Let's see how much we're seeing. Oh, you can see it right down there, so that's great. So you can see that nice plume of color right there, and that is in our unconfined aquifer. And I think I have one more to do right here. Let's see how much is coming out. Oh yes, so we have our nice plumes of color right there. Now, some people can look at these as sources of pollution if you're teaching a lesson, and you can start to take a look to see if these are moving. These plumes are not moving right now because we have a closed system. The water's not moving anywhere, so this would be an example of a lake that is possibly dammed up. Water's not moving. This is a very closed system. We're not getting more rain. The water's not going anywhere, so our plumes are not going to move. What I'm going to do is I'm going to tilt this pipe, and it's starting to drain. And you'll start to see our plumes moving. You'll also start to see our water levels being refilled. And let me step around and take a look. Okay. So I'm going to keep on refilling this. And we're going to see if we start to see the blue move. And the question is, where do you think that blue water within the groundwater would move to? Water is always trying to find an exit. It's always trying to go to the lowest point. Well, it can't go any lower than this confined layer, so it's going to try to find where water is exiting, which is our lake and our river. So we might start to notice that some of the blue, instead of just being a circle around it, is starting to move in that direction a little bit. Now this takes a while. Groundwater is moving through porous areas. It is moving through soil, through sand, through all kinds of minerals, and it's not going to be moving particularly fast. But you can see that the water is moving, especially as this demonstration goes on. You'll get to see that the plumes are no longer just completely around it, that they are going to start moving. So I'm going to add a little more color into these. Okay. So we have this one right here. The one right next to it. And this one right there. And I'm putting a lot in there just so that we can see it move a little bit faster. We can see a lot of that color. And if you notice, the ones that are closest to the exit of the water is going to be the ones that move the fastest, especially because this material is all the same. If there were gravel parts where the spaces between it were more open, or that's another way of saying it's more porous, the porosity is higher, that color would be moving quite a bit faster. So I'm just going to put some in here, and you can see that it's entering the same material, the same sand, so it's not going to be moving any faster. Now, if we want to see how fast some pollution can move through the water, we're going to go with our red. I'm going to fill this back up a little bit. Okay. I'm filling up our red, and what I'm going to do is I'm going to put this in our leaky landfill. So this is a landfill that has holes that hasn't been sealed properly, and we're going to see where that water starts to go to. I'm also going to put some down into here too, and this could represent if somebody had a leaky septic or something along those lines where the pollution is getting down into the ground. Alrighty. So I'm just going to keep on filling up this landfill. And you can start to see that these plumes are moving a lot more as time goes on, and this is what happens throughout our soils. The plumes are starting to go where the water's lower, and the red right now, it's sitting where it's at, and it has not moved a whole lot, but you'll start to see it follow where the other plumes have gone. Now, for the second part of this demonstration, we can start to see how wells influence our groundwater. So we're going to start pulling from our wells and see if any of the colors that we get in the soil are starting to come up through our wells. This is something you can think about if you have a well at home. You might want to know if your well is going into the unconfined aquifer or the confined aquifer, because right now most of our colors, especially our red, is in our unconfined aquifer, and that is where you can get a lot of groundwater pollution. So I'm going to start pulling from one of our wells in our unconfined aquifer. And you can start to see, it's not super dark, but there's a little bit of blue. There's a little bit of blue in here, and that is because one of our plumes was starting to go to our stream. But instead, as we withdrew our water from our well, that pollution decided to go straight up. And you can see too, this plume is going towards our stream, but if I keep pulling, I might be able to get it to go to our well too. So if you have an unconfined aquifer well, then you might be pulling from your groundwater. Ooh, oh no. I don't know if you can see how dark that is, but that's not just the blue. That is also the red. So we have some of the leaky landfill getting into our water. So I'm going to keep on doing that. And And you can see that's not a good sign. So it's always important to get well water tested often to make sure that you are not pulling from any sort of contamination sources. I'm going to fill up our landfill a bit. Okay, there we go. So it wasn't very clear that our landfill was getting all the way down here until we started to pull from our well. Our landfill was creeping across the top and going down to the lake. But as you pull water out of a well, it actually changes the flow of your groundwater. So this plume had started to go up. This plume had started to go down because we were creating a point where water was exiting the system besides our lake or our river. I'm going to plug up our lake or our river for a bit, let the water rise a little bit, and we can start to see some of the colors of the pollution that's in there. So once again, I'm going to pull from our well in our house, and you can see there's color in it. Now, I'm going to try to pull from our well that goes all the way down into our confined aquifer. So the only colors that we should see if this is actually confined is maybe a little bit of green, because that is the color that we put down there. If you have a confined aquifer well, you're only getting what has been put down there through reservation, or through reservoir, or through a lot of process of filtering. So you can see that there is no red in this one, which means that our leaky landfill has not gotten into it. So that is something that's nice about having a well that goes down into the confined aquifer. As long as that aquifer is confined and there isn't some cracks that go down into it and break through that confining layer, then your water should be nice and good. And you can start to see these colors collecting in our lake. And this is a sign that all of this area that is draining does drain directly into our lake. And the question is, if this were all pollution and not just some of the colors that we put into the piezometers for monitoring, let's say that those were examples of septic tanks or other things that were going down that were leaking, or maybe somebody had drilled in to put pollution down further where they thought it was in a confined area that we wouldn't have access to, but it wasn't. It can still get into our lake. But how do you clean it out? The first thing that is the best thing to do is to remove those points of pollution. So I'm going to start trying to remove some of those dyes that we had put into the piezometers. Because if that is pollution, we want to try to get it out. So the first step of cleaning our groundwater is to remove these sources of pollution. And then the second one is to let nature take its course. But you can see, as nature takes its course, that pollution is going to get flushed out of our groundwater, but then put into surface water, like streams, lakes, and whatnot. So what we want to do is make sure that we keep pollution away from basically anywhere on the Earth's surface, because it can get down into other areas. If we do have to put pollution somewhere, like a landfill, you want to make sure that it is confined. You want to trap it in a confining area, and that is what a lot of landfills do. They have layers of clay, layers of other confining materials to try to prevent it from leaking into our waterways. And that's why it's also really important to dispose of waste properly, so that you're not putting things into the landfill that can leach through confining areas or cause other issues. So I hope that this model has been a little bit of an education about how water moves through our earth. You can see that it is still moving a little bit. I'm going to drain this. It should start moving a little bit faster. But what we put into our land does affect our water, and what we put on our earth needs to be done wisely, because it's all a connected cycle, it's all a connected system. If you're interested in taking out a model like this, please reach out to our office. This model also goes very well with our Enviroscape model, which shows how surface water gets polluted from non-point source pollution, and that means somewhere where it's not coming directly out of a pipe going into our rivers. It would be something like this, where you put fertilizer on the ground, or leave your dog waste all over the place, and that ends up collecting into our waterways. So this is our groundwater flow model, and if you guys have any interest in taking it out, feel free to reach out to our office. We're Medina Soil and Water Conservation District. And if you like this video, please give it a thumbs up. If you're looking for other resources to go with an educational model like this, please check our description, and we'll have links to other educational material that ties into this model. Thank you very much.